Okay, guys, sorry this took so long, but this is the cardstock paper that if you want to watch this, it'll help. So this first example, we have f of x equals 3x plus 2 over x plus 2. So that is simplified as far as it can go, so we don't need to simplify it anymore. So let's find the x-intercepts. That's where you set the top equal to 0. So that means x equals negative 2/3. So my x-intercept is negative 2/3, 0. Now for the y-intercept, I'm just going to plug 0 in for all the x's. So we have 3 times 0 plus 2 over 0 plus 2, which is 2 over 2, which is 1. So my y-intercept is 0, 1. Vertical asymptote, set the bottom equal to 0. Move that over so you get x equals negative 2. There's that vertical asymptote. Horizontal asymptote, that's when we have to look at our little chart over here. The degree on top, that means the exponent. So the exponent on top, we just have the x, so the exponent is 1. The exponent on bottom is also 1. So they're the same degree, which means we're just going to set the leading coefficients. We're going to look at the leading coefficients, so we get y equals 3 over 1. So y equals 3. If there is a horizontal asymptote, then there is no slant asymptote, and nothing cancels at the beginning, so there are no holes. So let's just start graphing this. So my x-intercept is negative 2/3, 0. My y-intercept is 0, 1. My vertical asymptote is x equals negative 2. And my horizontal asymptote is y equals 3. Then we can draw that piece right there and that piece right there. Okay? My domain is negative infinity to negative 2, and then negative 2 to infinity. My range is negative infinity to 3, and then 3 to infinity. Let's do this one. So we have 6x minus 18 over x squared minus 4x plus 3. Simplify that, so you get 6 times x plus 3. Now let's factor the bottom. So that's, or x minus 3, that's what I meant. And then we have x minus 3, x minus 1 on bottom. Now those x minus 3's cancel, which means I have a hole at 3 for my x value. I just need to figure out where the y value is. So that simplified equation is 6 over x minus 1. And let's plug 3 into there. So f of 3 is 6 over 3 minus 1, which is 6 over 2, which is 3. So that hole is at 3, 3. Okay, now I'm going to go back and do my x-intercept. Well, at the top, we're just left with 6. 6 cannot equal 0, so there is no x-intercept. Y-intercept, plug in 0 for x, and you get 6 over negative 1, which is negative 6. So that's going to be 0, negative 6. Vertical asymptote, set the bottom equal to 0. You get x minus 1 equals 0, so x equals 1. Horizontal asymptote, the degree on top is less than the degree on bottom, so y equals 0. Slant asymptote, there isn't one because we had the horizontal asymptote. If you have a horizontal asymptote, you do not have a slant asymptote. Okay, now we can graph everything. So no x-intercept, we have a y-intercept at 0, negative 6. Vertical asymptote at x equals 1. Horizontal at y equals 0. Then a hole at 3, 3. That piece will draw right there, and that will draw right there. Okay, my domain here is negative infinity to 1, then 1 to 3, and then 3 to infinity. My range is negative infinity to 0, 0 to 3, 3 to infinity. Okay, let's do this one. So we're going to factor the top. Just kidding, that won't factor. So if it doesn't factor, to find the x-intercepts, we're going to put it into the calculator. Okay, so you're going to put that into your calculator to find those zeros. And you should get negative 7.60 and 1.60. And the way you do that, just go to y equals, plug it in, and then graph it, and then go second trace and go down to 0 to find those zeros. Okay, so those are my x-intercepts. Y-intercept, I'm going to plug in 0 for all my x's, and you end up with negative 12 over 4, which is negative 3. So my y-intercept is 0, negative 3. Vertical asymptote, you have x plus 4 equals 0, which means x equals negative 4. Horizontal asymptote, the degree on top is exactly 1 more than the degree on bottom. So there is no horizontal asymptote. We do have a slant asymptote, and I'm going to use synthetic division to find that. So I'm going to divide the top by the bottom. Put negative 4 on the outside, the coefficients on the inside, so 1, 6, negative 12. Bring down that first number, multiply, add, multiply, add. You ignore the remainder, and so we're just left with x plus 2. So my slant asymptote is y equals x plus 2. Then the whole, there isn't one. Okay, and then if we graph this, so negative 7.60, there's a point. 1.60, there's a point. 0, negative 3, there's a point. Vertical asymptote at x equals negative 4. And then a slant asymptote at y equals x plus 2. So it crosses at 2. Then we go up 1 over 1, down 1 over 1, and we can draw that right there. That just goes right along there, and that goes right along there. Okay, so my domain is negative infinity to negative 4, then negative 4 to infinity, if you're going left to right. Range is going to be negative infinity to positive infinity. Okay, let's do this next one. So we have x cubed minus 8x squared plus 12x over x cubed minus 3x squared plus 2x. Factor out that x. Factor those down, so you get x minus 6, x minus 2, over x minus 2, x minus 1. Those x's cancel, giving us a whole at 0. Those ones cancel, giving us a whole at 2. And I'm left with x minus 6 over x minus 1. Now I'm going to plug in 0 to find where that first whole is. That's negative 6 over negative 1, which is just 6. So there's that. Plug in 2. Get negative 4 over 1, which is just negative 4. And there's that whole. Okay, x-intercept, set the top equal to 0. So you get x equals 6. Y-intercept, plug in 0. And you get 6, but we had a whole at 0, 6. So we're not going to have a y-intercept. If your whole is the same as your y-intercept, so if you have a whole at 0, you are not going to have a y-intercept. Okay, that's something to remember. Now, vertical asymptote, set the bottom equal to 0, so you get x minus 1 equals 0, so x equals 1. Horizontal asymptote, the degree on top is the same as the degree on bottom. So then we look at the coefficients. The coefficients are both 1, so you get y equals 1. There is no slant asymptote. Then we can just graph all of this. So we go 6, 0, draw that point. No y-intercept. X equals 1, draw that point. Y equals 1, draw that. Asymptote, not point, asymptote. 0, 6. There's a hole. 2, negative 4. There's a hole. Then we can draw that and draw that. Okay? Now my domain on this is kind of a big one. So we have negative infinity to 0 because of the hole. Then 0 to 1 because of the asymptote. And then 1 to 2 because of the hole. And then 2 to infinity. Okay? Range, negative infinity to negative 4, negative 4 to 1, 1 to 6, 6 to infinity. Cool? Let's do this one. So if we factor that, you get 3x minus 4 and 2x plus 1 over 3x minus 1. There's no hole, so we can find our x-intercepts, set both of those tops equal to 0, and you get x equals 4/3 and negative 1/2. So you get 4/3, 0, negative 1/2, 0. My y-intercept, plug in 0 to the equation. You get negative 4 over negative 1, which is just 4. So that's 0, 4. And you could plug that into the factored equation, you'd still get 4. So it doesn't matter which one you plug it into. Okay? Vertical asymptote, set the bottom equal to 0, so 3x minus 1 equals 0. so x equals 1/3. Horizontal asymptote, the degree on top is greater than the degree on bottom, so there isn't one. Slant asymptote, we're going to use long division for this. So first, divide first with first. So 6x squared divided by 3x is 2x. Multiply, so 2x times 3x is 6x squared. 2x times -1 is -2x. Subtract, change those signs. Those cancel. -5x plus 2x is -3x. Bring down that next term. And then again, divide first with first. -3x divided by 3x is -1. Then multiply. Change those signs. And you're left with -5, but we ignore the remainder. So we're just going to ignore that. My slant asymptote is y equals 2x minus 1. And there are no holes here because nothing canceled. So now we can just graph everything. So 4/3, 0, -1/2, 0, 0, 4, x equals 1/3, and then y equals 2x minus 1. So it crosses at -1, goes up 2 over 1, down 2 over 1. We can draw that right there. And then that goes up like that, and that goes right there. So my domain is -infinity to, that is wrong. I'm just going to put the range up there too. The domain is not -infinity to positive infinity, sorry. The domain is -infinity to z 1/3, not 0, and then 1/3 to infinity. That's the domain, not -infinity to positive infinity. Okay, range is -infinity to positive infinity. Now let's do this one real quick. So if we factor this, we have 4 and then x squared minus 3x plus 2 over -2 x squared minus 4. -2 goes into 4 twice, so I'm just going to leave that -2 on top, and then the top factors to x minus 2, x minus 1. Bottom factors to x minus 2, x plus 1. Those x minus 2's cancel, and I'm left with a whole at 2. And that simplified equation is -2, x minus 1 over x plus 2. So I'm going to plug in 2, so you get -2 times 2 minus 1 over 2 plus 2, which is -2 times 1 over 4, which is -2/4, which is -1/2. So the whole is at 2, -1/2. Now my x-intercept, we have x minus 1 equals 0. Could you just set the top, and we don't have to deal with that -2 because it's not going to matter. So we have x minus 2 equals 0, which means x equals 1. So 1, 0. Y-intercept, plug in 0, and you end up with 1. Vertical asymptote, x plus 2 equals 0, which means x equals -2. Horizontal asymptote, the degree of P equals the degree of Q, so you look at the leading coefficients. That's -2 over 1, which is just -2. So we have a horizontal asymptote at y equals -2. There's no slant asymptote. So I'm going to graph that. 1, 0 right there. 0, 1 right there. X equals -2. There's that asymptote. Y equals -2. There's that. And then a whole at 2, common -1/2 right there. Then we can draw that, and we can draw that. Okay. My range, or my domain, -infinity to -2, -2 to 2, 2 to infinity. Range, -infinity to -2, -2 to -1/2, -1/2 to infinity. Cool? No video for this whole... This is a video. I am so struggling. There's no quiz for this. I'll see you guys when I see you. Make sure you're studying tonight. Hopefully this helps you. Bye-bye. Bye-bye.